Welcome to another edition of Math for No Reason. In this edition, we will be looking at this interesting problem. Let us consider the GP to power t, where t runs from 0, 1, 2, etc. So, as t runs from 0, 1, 2, etc., we get these terms 1, 2, 4, 8, 16, 32, 64, and so on. 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16, and so on. And now let us consider the sequence of the first digits of this term. For the first digit sequence, the first 4 terms comes as it is. The fifth term, 16, has first digit 1, so we have 1. For 32, we have 3. For 64, we have 6. For 128, we have 1. For 256, we have 2. For 512, we have 5, and so on. So this is the first digit sequence which is constructed out of the given GP. Now the question is that what fraction of the first digits are ones? Now to understand this, we have to first understand what does it mean to say a fraction of first digits of an infinite sequence. So let this sequence be called f1, f2, fn, etc. So the first digit sequence we are representing as f1, f2, fn, and we are looking at this ratio, and this is ratio up to term n, so I will call it Rn. So this Rn is the cardinality of this set divided by n. So the number of terms in the first digit sequence which are 1 divided by n. So it is the fraction up to term n. And then we look at the limit of this sequence Rn as n goes to infinity, and let us call this lambda. And this lambda, we will think of this as the fraction of first digits which are equal to 1. And we will try to find out the value of lambda. To prove this result, we will take recourse to the consequence of a very famous theorem of H. Weyl. Let us look at another question which is related to this. We'll see how later on, and see what result we get in that context. So let us look at the sequence xn, which is the fractional part of alpha n. So if alpha n is 2.75, then the fractional part of alpha n is 0.75. So this fractional part of alpha n is always a number between 0 and 1. So to prove this result, we will need a result which is somewhat advanced. So let us consider this sequence xn where alpha is an irrational number. Now consider this ratio. In the numerator of this ratio, we have the number of terms xn which belongs to this open interval AB, where 0 less than equal to a less than b less than equal to 1. So this open interval AB is a subinterval of the closed interval 0, 1 divided by n. Now as n goes to infinity, a deep theorem due to H. Weyl tells us that this ratio would converge to b minus a. And this result will be required for us to find this limit as n goes to infinity Rn. Returning to our original problems, let us find out the condition for which fj is equal to 1. Fj is the jth term of the first digit sequence. Now the jth term of the sequence will be equal to 1 if 2 power j would lie between 10 to the power a and 2 into 10 to the power a. If we look at 128, this lies within 100 and 200. If you look at 1024, it lies between 1000 and 2000, and so on. So whenever your 2 power j lies between 10 power a and 2 into 10 to the power a, where a is an integer, that's important, then we will have the first digit to be equal to 1. Now taking logarithm, what we get is a is less than equal to j log 2 is less than a plus log 2. So this means that 0 is less than equal to j log 2 minus a is less than log 2. So, if you look at the fractional part of j log 2, this belongs to the interval 0 to log 2. So, please be careful with the notation, because here this is indicating the fractional part, whereas here it is denoting the sequence. So, little problem with the notation, but be careful with it. Now, if we are looking at this sequence j log 2 and remembering the fact that log 2 is irrational, so if we consider this ratio, the number of fractional parts of j log 2 which belongs to 0 to 2, where j lies between 1 and n, divided by n, then this quantity converges to log 2 minus 0, which is log 2. The fraction of terms of the GP 2 power t, which has the first digit 1, converges to log 2 as n goes to infinity. Since log 2 is like 0.3010, so approximately 30% terms are 1 in the first digit sequence. It's a good point to stop. Thank you.